different ways that we can set it up. So we have waterfall model, we have agile, we have DevOps. So basically, we have different methodologies. All right. So last class we discussed about your waterfall model. Now, waterfall model is one of the oldest model that we have, and it's a good model when you have a very fixed requirement. For example, let's say you're looking for a mobile application. Now, if your requirement is fixed, like you know what you need, and that requirement is not going to change, then your waterfall model is a good model. All right, so you can use that to develop your applications, you can use that to develop your software. But if you're going to keep on changing your requirement, so basically your waterfall model cannot accommodate any changes. Once you give the requirement, it's very difficult to change it. And if you want to change it, then you'll have to kind of again start from step one. You cannot go back to any previous step. Like for example, let's say uh, your testing failed during the test setup. Your testing is not working as expected. So give me 1 minute, I'm getting a call.
Oh, sure.
Sorry, yeah. So at any point, let's say your testing has failed. Now you cannot go back to the previous step where you go and fix the code and you start the testing once again. We cannot do that. We'll have to again start from step one, which is to again understand the requirement. What is the requirement? What needs to be done? Then again set up your. You'll have to code it. All right. Then again you'll have to develop it, and then again you'll have to test it. Okay. So you will have to kind of start from step one and then do it again and again and again, and that can take up a lot of time when we talk about waterfall model. Now, to overcome that, your next model was introduced, which is your agile methodology. Okay, so let me share my screen.
Ravi, in real-time example, if we take, can we consider the basic games as an waterfall model project?
Basic games, is it?
Yes, like we know necessity, like we know exactly what we need to do, like left or right arrow to move the whatever the character is present. There is no any further update is required on that game, so that
You
we can consider.
can, but another important thing to keep in mind with your waterfall model is that unless you don't complete step one, you cannot go to step two.
Yeah.
Okay, like for example, unless you have not understood the requirement gathering completely, you cannot go back to designing or coding that application. Okay, so there is always a huge wait time associated with your waterfall model. So, as of now, in today's market, your waterfall model is very least used. Okay, so I would, for your example, I would still not go with the waterfall model. I would go with your agile model or your DevOps model. So, to overcome the challenges that we have in your waterfall model, your agile model was introduced. Okay, so sorry, 1 minute.
Um, Ravi, another doubt. Agile and spiral model, it's almost same, right? Just a few steps may vary.
Which model?
Spiral model,
Spiral model.
yeah.
Uh, let me look at what all we have in this. I mean, this is also iterative. So,
Yeah.
yeah, yeah, I mean, I would say yes. So you start with the risk analysis, engineering or development, and then finally review. Yeah, so this will also be more or less the same. Actually, Your agile, lean, spiral, DevOps, all of these are more or less the same. Okay, with a slight change as to how you are going to use it, but more or less they are same.
So we can
So
call them as an iterative models, or
correct.
in short.
Yeah, you can. So now under your agile or spiral or other models that we have now, what happens under this is, okay, other thing with your waterfall model is that you do a one single deployment, meaning everything will be deployed in one single shot. Okay. Now the problem with that is as a customer, you don't know what exactly you will be getting. Whatever the product that is going to be deployed, you don't know what you will be getting because you're doing a one single deployment. Now, to overcome all these challenges, we have your agile model. Under agile model, what happens is we basically break down the requirements. For example, let's say I'm looking for a mobile application. So first, I will set up your login page, or let's say first I will set up your characters, what all characters you want. So I will start coding it, I will develop it, I will test it, and then I will deploy it. Okay, so under this, instead of having one single deployment, the main focus here would be your client satisfaction. So making sure your customer is happy with what you are delivering, with what you are developing. Okay, so the focus here will be more on limiting the project scope. So you won't be working on the entire project at once. You will be trimming down the scope. Like, okay, this particular month, we are going to concentrate on what are the different characters you want. We will develop that, we will deliver that, we'll get back the feedback from the customer. And again, in the next month, again, we will repeat. So again, requirement gathering, coding, developing, testing, deployment. So we go through this cycle again and again and again. So what we do is we break down the requirements. So first month characters, second month, moving around as to how you want to play in the game, what all you want to do. We will do that. So again, in that we will do the requirement gathering, coding, testing, deployment, feedback. Again, third month we will take one requirement and again we will do the same thing. That is a agile methodology. So here the advantage you have is two things. One, as a developer, you will know whether your customer is satisfied with whatever you have developed or not. So each month you will, or each deployment, each release that you will do, you will get a feedback from the customer. Second, your customer is also aware as to what the product will look like, right? Because you're releasing shorter versions of it, your customer is also aware as to what exactly the application will look like once it is deployed, the entire application is deployed. That is simply your agile methodology. Does that make sense?
Yes, Ravi.
So the other advantage you have under this is, let's say for example, you have developed your characters, but the customer is not happy maybe with one or two characters. You can get that feedback and you can again work on it. You don't have to like go from step one and do it again, right? So you have that flexibility. You can get the feedback, and if something needs to be changed, you can change it. You can incorporate it in your product, and you can deliver it to your application to your customers. That is where your agile methodology comes in. Your agile, lean, spiral, and all these things. However, when we talk about your agile or any of these methodologies, you'll always have two separate teams. You'll have the development team, and then you have the operations team, and there is always a communication gap between them, and there is a dependency. Your development team will depend on the operations team, and the operations team will depend on your development team. To overcome that, we have your DevOps tool. All right, so this is also a methodology which consists of various tools. So instead of depending on people to do the work, you will be using various tools to do the work. So DevOps is not a tool or it's not a team, it is simply a process, or again, it's a methodology which consists of various tools that can be used to solve the problems between the development team and the operations team, hence the term dev and ops. So dev from developers, ops from operations together is known as your DevOps. So basically here, both the team will be working together, right? Everyone will be called as a DevOps and everyone will be working with different tools. So generally, when we talk about your SDLC, I told you, your SDLC it consists of different steps. right? So you have your let's say, let me put it here. So you have your requirement gathering. You will have design and coding. You will have testing. You will have deployment. You will have monitoring and your maintenance. Generally, whenever we talk about this, now each of these you can make use of different tools. So maybe you can use Confluence where you can store all of your requirement gathering, what needs to be used. You can make use of your Jira to create the different tickets and all that. For coding, you can use any of your coding tool, any IDE like Visual Code, into Eclipse, any of those things. Testing, or you'll also have one more, which will be your build stage. So building. So here you can use tools like Maven and Gradle, MS Build, and then so on. For testing, you can use tools like Selenium, JUnit, TestNG. You'll have different tools. For deployment, you can use Ansible, Chef, Puppet, um, SaltStack. For monitoring, you can use Grafana, ELK, Datadog, New Relic, and then so on. In addition to this, if you want to use containerizations, even that option is available. So you can use tools like Docker, Kubernetes, OpenShift. And if you're looking at automating your infrastructure setup, so you can have infrastructure as code tools like Terraform. You can use Plumi. You can use CDKs, all these options. So there are lots of tools when we talk about your DevOps, right? So everything will be done by tools. And I also forgot about your version control system. So you'll have your version control system, which will have your Git, GitHub, Bitbucket, um, then SVN, and then so on. So there are lots of tools. Now, in our case, we will be looking at your Git and GitHub. Then we will look at your Docker. We will look at your Maven, Jenkins, Ansible, Kubernetes, Terraform at a high level, and then your ELK. These are the tools that we are going to cover. So 1, 2, 3, 4, 5, 6, 7, 8 tools is what we are going to look at. Any questions until here?
Um, Only one thing. This will be worked under Linux environment, right? These all the
Correct.
tools.
Yes. So that's why I did a high level session for your Linux just to move around because that is what we are going to use to run all these tools.
Just a question. Can we use Ubuntu for this?
Yeah, yeah. Any variant of Linux can be used. Ubuntu, Red Hat, CentOS. As long as it is a Linux, it's fine.
Okay.
Ubuntu is just a variant. It's one of the version in your Linux.
Yeah.
All right. So we will start off with your first tool, which is going to be your Git and GitHub. So before we start off with your Git and GitHub, it's important that you understand your version control system. What is version control system and why we have a version control system? So any idea what is a version control system and why we need a version control system?
No.
So imagine you have a photo image, all right? You want to edit that image. Now, what will you do? Will you edit the original image or will you like make a copy of that original image and then edit it?
I'll make a copy, and
Why will you do that?
in case if I lose the copied or original one, I'll have a backup of another one.
Correct. So that is to mainly make your at any point if something goes wrong, you can always go back to the previous versions, right? Likewise, you can think of it as maintaining different versions of your data or multiple versions of your data. Now, imagine you have like you're writing some piece of code. So today you will write some piece of code. Tomorrow you'll write some piece of code. Day after tomorrow you'll write some piece of code, and then so on. So you're basically updating your code. Now, if something goes wrong, so let's say you deploy something to production, you want to go back, you want to revert back to the stable version of the code. How can we do that? That's where we can make use of your version control system or your source code management. So it is simply the management of your application code. Okay, like maintaining multiple versions, collaborating with multiple people. So all those things can be done by using a source code. So version control is a system that helps you to record your changes. So at any point, any changes that you will make to a file or a set of files, your version control system will help you to keep a record of it as to when a change was done, who made that change, why that change was done. All that record will be maintained by your version control system, and any of these changes you will make over a period of time, right? It will keep a record of it. Now, what's the advantage of this? Now, let's say, for example, you deploy something to production and it fails. Now, you have 10 people in your team. How will you know who made that change, right? Who deployed that change, or when this change was done, or why this change was done? How will you know that? That's where your version control system can be useful to keep a track of all these things. So if you're a programmer, you would want to keep every version of the layout or changes you make to the code. So even if it is a one line of change, you still want to keep a track of it, right? You still want to keep a record of it. That's where you can make use of your version control systems. So you can do this by making use of a version control system. The other advantage you have with this is that it also you to revert back. Like for example, again, now you have version 1 and then version 2. You deploy the version 2, but it failed. Your application is not deploying as expected. So you can revert back to version 1. And this is possible if you are using a version control system. So it allows you to revert your selected files back to the previous state, revert the entire project. So you can either choose to revert specific files, or you can choose to revert the entire project to the previous state. You can also compare your changes over time, like file 1 with file 2, you can do a comparison. See who last modified something that might be causing a problem, who introduced an issue, when it was introduced, and many more things. Right? So all of this can be done with a version control system. Is that clear?
Yes, sir.
So let's say you have file one, and within this you will let's say you'll write something and we'll call it as version one. Again you will update it. Let's call it as version two. And again you will update it. Let's call it as version three. So if you want to maintain this multiple versions of your data, we make use of your version control system for that. All right. So at any point, if you want to maintain multiple copies of the data, okay, simply maintaining multiple versions of your data, we can make use of your version control system. Now, when we talk about your version control system, very common will be your local version control system. So basically using your local machine. Now, let's say I'll tell you that, hey, can you please generate an Excel sheet with XYZ data? So what you will do, you will pull all the data, you will put it in the Excel sheet and you'll send it to me. Now I'll tell you, hey, can you please add some more data to this? Now you have two options. You can either in the existing file itself, you can add more data, or you can create a copy of that file and add the new data, so that you have both your old data, the original data that you had, and the updated data as well. That is something you will do on your local machine. So many people's choice of version control method is to simply copy the files into another directory. So what you will do is you'll maintain a backup folder where you will maintain all of your original files, right? Now this approach was very common because it is very simple, but also it is very error prone. So there are high chances of something failing, right? So you could easily forget or accidentally write to the wrong files or copy the wrong file. So common issue, right? You might forget where you have maintained your backup files, or you might accidentally overwrite the changes, or you might delete the wrong files. This is all very common thing. So to deal with these issues, developers developed a local version control system that had a simple database. So a local version control system was introduced where you will have a local database, and this database will keep track of everything. So now the most popular tool was a system called revision control system, which keeps track of your version control system on your local machine. However, the problem with this was, how do we collaborate? Like, this was fine for only one person, but what if there were multiple people in the team? How do you collaborate with multiple people in the team, right? So that's where your next model was introduced, which is your CVCS. So this is very commonly used. So we have your CVCS, and then we have your DVCS. So CVCS, it stands for Centralized Version Control System. So this will be centralized version control system, and then you will have the distributed version control system, right? Two types mainly. So the next major issue that people encountered was that they wanted to collaborate. So people wanted, like, let's say you want me, we want to collaborate. So whatever the changes I will do, I want to share that with you, or whatever changes you are going to do, you want to share that with me. All right. So to deal with this problem, your CVCS was introduced, which is your centralized version control system. Now, under this, what happens is you will have one single server, which we call it as your central repository. Okay, so CVCS has a single server that contains all the version files, and a number of clients can connect, check out the files from the central place. So basically, clients are nothing but us, the developers. So what we will do is we will maintain one central repository, and then we will start connecting to this central repository. So whenever I will make any changes, I will update it, I will push it to the central repository. And this central repository will be accessed by all of us. So whatever changes I will push, you can see it, and whatever changes you will push, I can see it. That's your centralized version control system. So now we have a central location where we can maintain all the version of the data. So whatever changes I have, I can push. Whatever changes you have, you can push, and we can start sharing our data with each other. However, this also has some downside. One, this acts as a single point of failure. So if my central repository goes down, and if you have not maintained any proper backup of the data, the entire code is lost. And the second issue is your internet. You need to be connected to the internet always to work with this.
So based
Questions?
on connectivity, yes, based on connectivity, this central repository should be always in domain. If in case if goes out of domain, then all other local machines will be collapsed, right?
So this is not domain level. This is internet based. Okay, so this will be on an internet.
Okay.
Okay. So yeah, so if the internet is down, then you can no longer work with this. All right, you will need to have that internet connectivity. Make sense? So this setup offered many advantages over the local version control system. So compared to the local version control system, this has many advantages. For example, everyone knows to a certain degree what everyone else was working in the project. So, I know what you are working in the project. You know what I am working in the project, right? So, to a certain degree, we know it, right? However, this setup also has some serious downside. Okay. So the most common is a single point of failure. That's the most common issue. So if the server goes down, then nobody can collaborate or save any changes. So like I said, if the central repository goes down, then we can no longer collaborate. We can no longer share our work with each other, right? And if the hard disk in the central server becomes corrupted without any proper backups, then you lose everything. Okay, so again, if you have not maintained a proper backup of your project, if you have not maintained any proper backup of your data, and if the central server goes down, you are going to lose everything. Questions?
No, Ravi.
So to deal with this problem, your next methodology was introduced, or the next model was introduced, which is your distributed version control system. Now, under the distributed version control system, again here also you'll have a central repository. So this is where your DVCS comes to your rescue. So in a DVCS, clients do not just check out the latest snapshots of the files, rather they fully mirror the repository, including its full history. So you'll have your central repository here also. However, on each of the machine, on each of the developer machine, we will also have something known as local repository, which is a full copy of this central repository. Now, the advantage of this, so this single point of failure is gone. So even if my central repository goes down, I can easily recover the project from any of the local repository. Or if the local repository goes down, I can recover from any of the central repository. One. The second advantage is even if you don't have internet connectivity, you can still continue working. So you can update the code, you can commit the code and everything. And once you get the internet connectivity back, you simply push it to the central repository, which can be shared with other developers. Right? So thus, if a server dies and these systems will collaborating up to the server, any of the client repositories can be copied back up to the server to restore it. So, any of the repository goes down, you can always restore it. Every clone is basically a full backup of all the data. So every local repository that we are creating, you can simply think of it as a backup of the data. Questions?
Hello, Ravi.
Next, we are going to look at your tools. So when we talk about your source code management, we have different tools that are available for us. Following are some of the tools that we have for SCM. So we have Git, we have Git, Mercurial, we have Perforce, SVN, GitLab, Bitbucket, Helix Core, Calithia, Visual Studio, Team Foundation servers. There are lots of tools that you can choose from for your version control system. Now, Git and GitHub, GitLab, Bitbucket, these are very commonly used version control systems, right? So let's talk about your history of your Git, how Git started. So Git began with bit of a controversy. Actually, there was no plan of creating your Git, but there was some controversy, and because of that, your Git tool was introduced. So in 2002, there was a community who was working on this Linux kernel. Now, this Linux kernel was an open source software project, and this community they were using a tool called Bitkeeper, which was a DBCS tool at that point of time. However, this Bitkeeper tool was a licensed tool. And for this community, the Linux community, they were getting it for free. Okay, they were not paying any money. Now, in the year 2005, the relationship between the community that developed the Linux kernel and the company that developed the Bitkeeper, it broke down, and the tool's free of charge status was revoked. So basically, in the year 2005, the company said that, okay, you will no longer get the tool for free, you'll have to pay money. And this prompted the community to develop their own tool based on the lessons they had learned when using the BitKeeper. And Git was introduced in 2005 and has been evolving and maturing ever since. Okay, that's how your Git was introduced. Make sense?
Yes, sir.
So talking about the introduction to Git, so Git is your DVCS, distributed version control system. And the major difference between Git and any other version control system is the way Git thinks about your data. So the way Git treats your data. Now conceptually, most of the systems, most of the version control systems, they will store this information as a list of file based systems. So they will treat your data as a file, like file 1, file 2, file 3, file 4, and then so on. All right. But your Git thinks of your data more like a series of snapshots. So every time you commit your data, it will keep a snapshot of it. That's how it treats your data. Because with Git, every time you commit or save your changes, Git is basically taking a snapshot. It is basically taking a picture of what all your files look like at the moment when you committed it, and then stores a reference to that snapshot. Okay, that's how it treats your data. So let's say you have 10 files, and if you commit it, it will simply take a snapshot of those 10 files. It will take a picture of those 10 files, and it will add a reference to that. So whenever you want to refer back, you can use that reference ID, and you can refer back to that data, to that 10 files. Now, when we talk about your features, so one is it is distributed. So allows distributed development of code. Every developer will have a local copy, which is a local repository of the entire development history, and changes are copied from one repository to another. So from your local repository to central repository, or central repository to local repository. Then compatible. So compatible with existing systems and protocol. So SVN and SVK repositories can be directly accessed using Git SVN. So you can use it with any system you want. Non-linear. So supports non-linear development of software. So for example, let's say you're working on issue 1. Now suddenly you get issue 2, which is high priority. You can always jump from one issue to another issue, and you can start working on it. So it's not like I'm working on issue 1 and I have to complete it, only then I can work on any other issue. It's not like that. It follows a non-linear approach. You can work on anything at any point you want. So it includes various techniques to navigate and visualize non-linear development history. Then branching. Now, this is one of the very important feature that we have in your Git. We will be talking more on this later on, but it only takes a few seconds for us to create and merge our branches. Okay, so master branch always contains a production quality code. So by default, we'll have one branch, which is a master branch or your main branch, and this will always contain our production quality code. And then lightweight, so uses lossless compression technique to compress the data on the client's side. So it automatically compresses the data so that the data size is lesser. Speed. Now fetching the data from local repository is 100 times faster than remote repository. See, when you're working with a local machine, you don't need any internet connectivity. But if you're working with a remote machine, remote repository, you need to have the internet connectivity. Now, because you're working with a local repository, it is 100 times faster than compared to working with your remote repository. So Git is one order of magnitude faster than other version control system tools. And then open source. So you can modify the source code according to your needs. So you can, if you want to create your own version of your code, you can do it. Reliable. So on events of system crash, the lost data can be easily recovered from any of the local repositories of the collaborator. So, like I said, let's say if your central repository goes down, you can easily recover the data from any of the local repositories. So it is very reliable. Secure. Uses SHA-1 to name and identify the objects. Every file and commit is checksummed and is retrieved by its checksum at the time of checkout. So it uses this something known as SHA value or hash value to commit your changes. So we'll talk about that more later on. It is economical. So this is released under your general public license. That means anyone can use it. So it is free to use. So all heavy lifting is done on the client side. Hence, a lot of money can be saved on costly servers. These are your features when we talk about your Git. Questions?
No, no.
Now let's talk a bit about your repositories. Now, repository is simply a location where you're going to store your data. So anywhere you're going to store your data, we can call that as your repositories. So your repository is simply a storage space or it's a directory where your projects can live. So basically the location where you'll be storing your project related data. So it can be local to a folder or it can be stored a storage space on GitHub or any online host. Because you can store it on your local machine, you can store it on your remote machine, anywhere you want, you can store it. Now within this repositories, you can store whatever you want. It can be your core files, it can be your text files, image files, you name it inside this repository. So basically you can store whatever you want. Any kind of data you want, you can store. So generally when we talk about your repositories, they can be divided into two types. We have the local repository and then we have the central repository. So your central repository, it is typically located on a remote machine, like a remote server where it will be running. Exclusively consists of .git repository folder and then meant for team to share and exchange data. So whenever we talk about your central repository, it is meant for people. Okay, it is meant for new multiple people in a team to share and exchange that data. And then you have the local repository, which is typically located on your local machine. So this resides as a .git folder inside your project's root, and only admin of the machine can work with the repo. So it is, um, restricted only to one person who is owner of that machine. Any questions?
No, no.
Okay. So next we are going to talk about your installation. Now your Git can be installed anywhere you want. It can be your Linux machine, it can be your Windows machine, it can be your Mac OS machine. Anywhere you want, you can install it. Okay. So I'll show you how you can do this on the Linux machine, but like I said, you can install this anywhere you want. So it is platform independent. So before you start working with your Git, you need to install it on your machine. So you can either install it as a package or via another installer, or you can simply download the source code and compile it yourself. So if you want to install this on the Linux machine, you can use this below command. So you can, if you want to install on Red Hat or CentOS, you can use this command. And if you're on Ubuntu, you can use this apt install git. For Mac OS, you can download the package, and for Windows also you can download the package. Now, however, you can simply go to this git-scm/download. That's the link where you will have the instructions for installing Git on your respective machines, anywhere you want. Okay, so here you can see this is for your Mac OS. Then you will have your Windows, and then for Linux you'll have the instructions. Okay, you can use any of these things. Now we will be using your EC2 instances. All right, so let me quickly show that. So I'll go to EC2 and I'll quickly launch one EC2 instance. Okay, I already have an instance. Let me use that. This is, instance. So you can validate whether you have Git or not by using this git-version command. As you can see, command not found. So for this, I can use this yum install git, and this will install the tool, the client for me, which I can use to start working with my Git. So my Git has been installed. You can validate the version now by running this git-version, and there's my Git installed. Questions?
No, Ravi.
I'll stop here. Next class, I'll show you how you can create your GitHub account. So GitHub will be your central repository, okay, where we are going to store our central data. That will be our GitHub account. So we'll look at that, and then we'll start off with your commands. So you can start working with your Git. We will look at that. Okay.
Okay.
I think I'll see you on Monday then.
Yes.
Thanks. Bye.